Good morning, afternoon, everyone, depending on where you may be joining us from today. My name is Chace Eldridge. I'm an Aviation Safety and Engagement Advisor here at CASA. I work within our industry engagement as well as our industry consultation and government engagement areas out of our Brisbane office. My background is as a pilot and instructor, and I've been involved in obviously private operations as well as Part 135, 141 and 121 operations. Welcome to our webinar today. We're going to be focusing on weather-related decision making. This webinar is part of CASA's ongoing pilot safety campaign, hosted on our Pilot Safety Hub. The current focus of our campaign is weather and forecasting, with a raft of information and resources available to you on that website to help you make better decisions and manage your own risks. This is the last of the webinars for 2024 and the last of them related to weather and forecasting. In the new year, the focus turns to flight planning. I just saw someone joining us from Uruguay. That's very cool. I saw you going to be hosting a game in the next FIFA World Cup, or sorry, the 2030 FIFA World Cup. So good day for Uruguay. These webinars are a great opportunity to hear directly from industry experts. And shortly, I'll be introducing our guest for today, Manager of Transport Safety from the ATSB, Lee Ungermann. Firstly, thank you for joining us. We understand in the online environment that people's attention spans are finite, time is precious. Many of you are likely running businesses in between classes, so we'll do our darndest to keep this webinar short and sharp. We want the time to be as useful as possible. There's a lot of people that do join these webinars. We've got 80 at the moment, so your cameras and microphones will be automatically switched off. You are more than welcome to use that chat functionality via the button at the top of your screen with questions and comments throughout. The webinar is going to be recorded, and that recording has already begun. It's for inclusion on our Pilot Safety Hub on the CASA website, and the link to that Safety Hub is on our homepage, front and center there, so you can't miss it. As I mentioned before, there's that chat window at the top of your screen. We do encourage you to ask questions right throughout the webinar. There will be a dedicated time towards the end of our presentation today to answer questions, and Lee will answer as many questions as we're able to, but anything we don't get time for, we'll make sure we get back to you via email in the coming days. We hope to have this done and dusted within the 45 minutes and get you back going with your day. Now, what are we going to be talking about today? I'm going to begin by highlighting a few of the key themes that we'll focus on throughout the presentation, in particular why decision making is often the key factor in whether weather is safely negotiated, noting that we as pilots all ultimately have access to the same information, but usually the difference in outcome comes down to what we decide to do with that information. After that, Lee is going to take us through a case study of weather-related decision making and share some of the contributing factors from that accident for us all to learn from. And following that, as mentioned earlier, we'll answer as many questions and have discussion in the remaining time, and continue to make full use of that chat function as we go. So, why is this topic so important that it warrants its own webinar? Decision making is how we practically implement risk management based on our flight planning, the environment around us, our own experience, and there are so many different influences here. We could go on. A few things that we as pilots are going to consider could be, how much holding fuel am I going to need? How fast should I fly to get there? How fast should I fly to get through this particular weather formation? What's the latest time I could safely arrive at my destination? Should I wait this out? Should I divert? Should I carry on or go home? Ultimately, decision making touches every aspect of our flight, and we as pilots in command must remember that we're solely responsible for managing our risks and ensuring the safety of our passengers. Aviation is a highly dynamic environment. Things are constantly changing. Our safety rests largely on being able to continually manage risks and then make and apply good decisions. This is an important point because decision making is not a one and done type thing. It's a continuous process of review, and we'll touch on some of the ways pilots can do that in just a moment. Pilots need to be able to identify changes in the environment, understand those changes, and project forward in order to make appropriate decisions. This can be very challenging, particularly in foreign environments or conditions in times of high stress. Now, the more tools and resources we as pilots can draw upon and effectively being the key word there, utilise, the better our decisions are likely to be. Some ways of doing that can be through improving your own knowledge, such as by attending our webinars like this one today. It's a way of improving the number of tools you can draw upon in challenging scenarios, challenging weather-related scenarios, and free up mental capacity for analysing any novel situations that do arise. Some examples include we're able to make better decisions if we have all the available weather forecasts available to us and we know how to use them, or we know how to accurately use all the aircraft systems and functionality available to us, including automation, which might be a theme we touch on later on. We're going to post some links in the chat to some online resources that delve quite deeply into the topics we discussed today, so we encourage you to use them. Another popular and effective way for maximising the success during unexpected, critical, non-normal, any operative word you want to use, event is through the use of decision-making models. Now, you've no doubt come across versions of this already, whether it be the old adage of aviate, navigate, communicate, or any other model that exists. Personally, I've used ones like FDODA. The link Courtney's going to post in a moment works through Pilot, and that's one of the A5 safety cards CASA has. But these mnemonics assist us by giving us a pseudo checklist or a flow, I guess, to follow to make sure we make best use of all the information available and at hand. We use ATSB case studies quite a lot in both our online safety products and in our face-to-face and online AvSafety seminars and webinars. A continual theme that we see in these weather-related accidents, and unfortunately there are quite a number of these, and often they do end up with tragic outcomes, is that the pilot had all the relevant information to be able to maintain the safety of flight, but still they ended up in an accident. We also see that there is no one pilot more likely to make these unsafe weather-related decisions, and even experienced pilots can find themselves spatially disorientated when flying in degraded visual conditions. It's often difficult to explain retrospectively why pilots made the decisions they do and why they ultimately resulted in tragic outcomes, like we're going to see in today's case study. However, a common theme is a perceived pressure from the pilot that they need to continue on with the flight, and it often correlates with how far into that flight they are, and can be for a variety of reasons, whether that be the aircraft needs to get to a maintenance organisation because something is due by tomorrow, or I've got friends waiting for me, or the weather's not going to clear for days after this. Could be any sort of reason. There's an ATSB research report, which I believe is in one of the links we provided earlier, and it is an older one, I recognise that, that found the chances of a VFR into IMC encounter increased as the flight progressed and reached a maximum in the final 20% of a flight distance. This highlights the dangers of pilots pressing on to reach their destination, and the regularity of these accidents still occurring show that these findings remain very relevant. Now, speaking of the important work the ATSB conducts, it's my pleasure now to hand over to Lee Ungermann, Manager for Transport Safety with the ATSB. Lee can introduce himself and walk us through the investigation that will no doubt have many tangible takeaways for us and assist with our flying moving forward. Handing over to you, Lee.
Thank you very much, Chase. Really appreciate the time today, and thank you, ladies and gentlemen, for the opportunity to present. Good morning or good afternoon, depending upon which state you're in. Today's discussion will be a case study into weather-related decision making. So to begin with, just like to introduce this particular accident, which was in 2021, involving a Vans RV7A. Now, the aircraft was registered X-Ray Whiskey India. I'm going to refer to it today as XWI. Now, XWI was being operated on a private flight under visual flight rules from Winton in Queensland to Bowen in Queensland. Now, the pilot, who was the sole occupant and the owner of the aircraft, had been on a multi-day tour in company with 3 other pilots. Each of those were operating their own aircraft. Now, about 2 hours after departing Winton and about 90 kilometres to the south of Charters Towers, the aircraft sustained an in-flight breakup. Unfortunately, the pilot was fatally injured and the aircraft was destroyed. This presentation will look at the decision-making of the pilot in relation to VFR into IMC flight, with the sole purpose of getting you to think about your own weather-related decision-making. Now, there's no doubt there's varying levels of experience online today, but I encourage you to substitute your own operations into this scenario before you jump to judgment over the pilot's actions. Think about how this type of scenario could easily weave its way into your own operations. Now, for the flight on the day, the Bureau of Meteorology forecast indicated that conditions were forecast to deteriorate in the area, down to 1,000 metres visibility in isolated thunderstorms with showers, rain, broken cloud from 800 feet to 10,000 feet, severe icing, turbulence, and also turbulence was expected within the proximity of isolated thunderstorms and cumulonimbus. A witness at Cattermole Station, which is about 100 kilometres northeast of Winton, heard an aircraft overhead the station for a period of time that was consistent with the recorded data from XWI. However, they were unable to visually identify the aircraft due to the presence of fog. Just go back, sorry about that. A witness at Pajingo Station, which was about 17 kilometres to the northwest of the accident site, recalled hearing an aircraft operating in the vicinity at about 1,000 feet. Now, they didn't see the aircraft in flight, but indicated that the weather at the station was heavily overcast and raining off and on for most of the morning. The night before the flight to Bowen, the pilot was contacted by a witness, and they recalled to ATSB that despite the forecast, the pilot had expressed a strong desire to remain with the group, even though the predicted weather may not have been conducive to visual flights. Now, prior to departure on the day of the accident, all the pilots got together to discuss the weather prior from their departure to Winton as a point of concern. And whilst the weather at Winton was suitable for VFR flight, en route, the weather was degrading. So consequently, all the other pilots elected to fly to Bowen under instrument flight rules or IFR, while the pilot of XWI, being restricted to operating in visual meteorological conditions because of his licence, departed under daytime visual flight rules under a VFR flight plan. Now, prior to departure, an offer was made to the pilot of XWI that should the weather be too bad for VFR flight, one of the group would return and pick them up and take them to Bowen. The accident site was located almost directly below the last known reliable recorded data point in open bushland with the ground that had been significantly softened by rain. The wreckage was distributed over a distance of about 1.5 kilometres, with the larger and heavier aircraft components located closer together, and the lighter, smaller sections of the wreckage found to the northwest of the main wreckage area, which was consistent with the forecast wind direction on the day. In essence, this was a typical in-flight breakup scatter pattern. Now, all major aircraft components were accounted for, and there was no evidence of any pre-impact defects. So this raised a number of questions as to the potential cause of the in-flight breakup. And ATSB analysis began on the failure modes of the main wing components to ascertain whether it was weather-induced gust loads, pilot-induced manoeuvre loads, or perhaps design and build defects that may have been a factor in the structural failure. So for this, we needed to look at the aircraft flight data quite closely and other accidents that may have occurred. Now, two previous accidents involving Van's RV7 or 7A variants were identified. And those in-flight breakups involved high rates of descent and exceedance of the never exceed speed or VNE. And these demonstrated very similar airframe failure modes to that of XWI. The New Zealand Civil Aviation Authority investigation concluded out of their investigation that their aircraft had entered a high-speed descent from an unusual attitude. The pilot didn't recover the aircraft from that unusual attitude or the subsequent high-speed descent, and that the in-flight breakup occurred as a result of rudder flutter as the aircraft airspeed exceeded the design limitations. The Canadian Transport Safety Board concluded from their investigation that after painting of the rudder, it was not likely balanced, and as a result, the rudder was susceptible to flutter at a lower speed than design, and the aircraft was over the maximum aerobatic gross weight during those manoeuvres. They also concluded that during the manoeuvring sequence, the speed of the aircraft reached 234 knots, exceeding the 124 knot manoeuvring speed and the 200 knot never exceed speed. The aircraft encountered either flutter or overstress of some rudder components, and subsequently the vertical stabilizer and parts of the rudder separated from the empennage during flight. Now, this was extremely useful for the ATSB investigation. However, our Achilles heel at the time is that we were missing the last 90 seconds of our recorded data before the in-flight breakup. So we'll take a look now at a little bit about the aircraft track and some of the decision-making that the pilot made during the flight. Now, about a half an hour after takeoff, when the aircraft was near Catamount Station, again, 100 kilometres northeast of Winton, the aircraft descended down to about 500 feet above ground level. The aircraft then conducted two right orbits, about 7 kilometres to the southwest of the station, at indicated airspeeds as low as 25 knots, before rapidly descending to less than 200 feet. Now, if anyone online knows the stall speed of an RV7 offhand, it's 86 knots in the clean configuration and around 50 knots in the landing configuration. The data then showed that the aircraft climbed back up to about 1,000 AGL, and then about 3 minutes later, when overhead the actual station airstrip, the aircraft's airspeed reduced to about 43 knots, while the aircraft conducted a right turn. It then rapidly descended to less than 50 feet AGL before climbing away from the station. So now we'll take a little bit of a look at the wider view of those operations around that Catamount Station area. And what it actually showed us was that XWI recovered at very low level from stalls overhead the station, and then navigated at low level back to its original track, and then turned towards Winton, which of course, as we knew at the time, was where the good weather was. Now, this on face value appeared to be a very good decision to return to the departure point, given the recent low level stalls and the near collision with terrain. However, at about 08:38 or 8:38 in the morning, and about 11 kilometres after turning towards Winton, the aircraft then conducted a left climbing turn and recommenced a track towards Bowen, climbing to a little bit over 10,000 feet above mean sea level. Now, about an hour later, XWI descended to about 1,000 feet AGL and conducted a large left orbit and then climbed back up to 9,000 feet. Now, this behaviour is consistent with scud running or trying to find a visual flight path through inclement weather. About 15 minutes later, the aircraft entered into a series of manoeuvres which led to the in-flight breakup. Now, initial data plots between the Dynon Skyview that was on board the aircraft and Aerion data provided by Air Services had continuity gaps and unreliable data points. So this still didn't give us visibility of the final in-flight breakup sequence, and seemingly exhausting all of that available data, the cause appeared to be inconclusive. But communication with the aircraft kit manufacturer now became a priority to understand the common airframe failure modes. So a review of other accidents and similar failure modes seemed to indicate that high-speed control surface flutter was a possible safety factor. Now, without reliable data, providing definitive proof, we couldn't assume this to be the case. So through our contact with our NTSB counterparts, we contacted VANS for information and history on in-flight breakups involving this type of aircraft. Now, VANS were incredibly helpful and had been monitoring these accidents, and they were actually proactively working on ways to prevent them. So after providing some information under Section 62 of the Transport Safety Investigation Act, they identified that this was the 6th in-flight flutter event of an RV7 or RV7A variant. In all cases, the last recorded airspeed was above the margin required for FAR 23 of 220 knots. The never exceed speed for the RV7A is 200 knots. An operation over this speed cannot guarantee structural integrity. So again, our last 90 seconds of flight was not originally accounted for. And this was likely due to power disruption during the flight, the in-flight breakup. So further data was able to be identified. However, subsequent data recovery found that an additional 70.5 seconds, and it really assisted us in identifying the final stages of flight. So about 2 minutes before the in-flight breakup, while climbing slowly through about 8,700 feet at around about 120 knots, the aircraft entered into an abrupt climb and reduced speed back to 56 knots before turning right and tracking southwards in a descent with increasing speed. After a further right turn in a shallow but increasing descent, the pilot would have received multiple over-G oral alarms as it passed through 185 knots in a 40-degree turn, until countering that turn rolling left until almost inverted with a 39-degree nose-down attitude. About 6 seconds before the in-flight breakup, the aircraft had increased speed above its V&E limitation of the aircraft and continued to accelerate until about 224 knots with an increasing trend before the data stopped being recorded. So ATSB started its analysis process, and we focused on the pilot experience and other characteristics of the actual pilot. So the pilot was a 74-year-old male and held a valid basic Class 2 medical certificate. They held a valid private license aeroplane issued in 1975 and was qualified to fly by day under visual flight rules. So the pilot had a total experience of about 277 hours prior to the accident flight, with a 30-year break after being initially qualified. ATSB also then began to look at the flight into the non-visual conditions. An analysis into that indicated from the weather information that for at least part of that flight, the conditions would not have been suitable for VFR flight, and that after departure from Winton, the pilot likely entered instrument meteorological conditions in the vicinity of Cattermole Station. And this most likely led to spatial disorientation and a subsequent stall, loss of control, and low-level recovery. Now, on multiple other occasions during the flight, the pilot most likely attempted to avoid reduced visual conditions by significant variations in altitudes, conducting orbits, and deviations from track. Now, when south of Charters Towers, it's likely that the pilot again entered into reduced visual conditions, and the recorded data indicated that abnormal flight maneuvers commencing with an abrupt turn to the south. Analysis of that recorded data, coupled with the increased likelihood of reduced visual cues, indicated that the pilot most likely experienced spatial disorientation in the period immediately prior to the in-flight breakup. In the analysis of the in-flight decision-making, it was very likely that after the near collision with terrain at Cattermole Station, the pilot had decided to return to Winton. However, about 11 kilometres into the return journey, the pilot elected to resume course to Bowen. Now, this may have been prompted by airborne communications on weather and flight visibility altitude from the other pilots of the group who were travelling to Bowen. However, most likely unbeknownst to the pilot of the accident flight, they may not have been aware that the other 3 aircraft were tracking about 30 kilometres to the south of their position and may have been less affected by the weather encroaching from the north. Now, although the pilot was aware of the forecast weather and had already encountered IMC, they still continued towards Bowen. The witness that spoke to the pilot the night before the accident about the forecast weather indicated that the pilot had a strong desire to remain with the group. So therefore, the pilot probably had some self-imposed motivational pressure to continue towards Bowen despite those deteriorating weather conditions. Now, there was no operational reason that we could find for the pilot to continue the flight, given that they had plenty of fuel to return to Winton or divert to other aerodromes away from that adverse weather. And in terms of the in-flight breakup, analysis indicated that the aircraft accelerated past its never exceed speed, and it was highly likely that this initiated the rudder flutter, which led to the catastrophic failures of the aircraft structure and subsequent in-flight breakup. Now, examination of the aircraft wreckage did not identify any pre-existing defects. However, the wreckage at the accident site indicated cascading failures that likely followed from the rudder and vertical stabilizer separating from the aircraft. And subsequently, the horizontal stabilizers likely failed and unbalanced the aircraft's aerodynamic forces, and that rapidly pitched the aircraft downwards, and that aerodynamic overload on the main wing structure resulted in the right main wing spar failing in a downwards direction and the right wing separating from the aircraft. The ATSB report concluded the following. So in terms of contributing factors, the first was that the pilot had departed for the flight from Winton to Bowen, Queensland, knowing that the weather conditions en route were unlikely to be suitable for VFR flight. The pilot likely entered weather conditions not suitable for flight in visual meteorological conditions, leading to spatial disorientation and loss of aircraft control. And that the aircraft's speed exceeded V&E, or never exceed speed, or maximum airframe speed, leading to rudder flutter, airframe structural failures, and a subsequent in-flight breakup. There were some other factors that the ATSB identified that increased risk, and those were that earlier on in the flight, the pilot had entered degraded visual environment over Cattermole Station, and that most likely resulted in spatial disorientation also, which resulted in a loss of control, stall, and subsequent low-level recovery. Now, although the pilot turned back towards Winton after the near collision with terrain at Cattermole Station, the pilot then resumed the flight towards Bowen, further into those degrading weather conditions. There were some other findings that the ATSB also made, and these were that there were no operational reasons for the pilot to continue the flight to Bowen, and that the pilot probably had self-imposed motivational pressure to continue the flight. Now, the real tragedy is that the Dynon Sky View that the aircraft had fitted had a wing leveling function and an autopilot, but the pilot didn't know how to use them effectively, and the pilot was in radio contact with the group for most of the flight. Add to that the pilot would have been in radio range and able to talk to Brisbane Centre at any time at the altitude that he was at, which may have assisted in avoiding and dealing or helping to deal with a flight into VFR into IMC. Now, ladies and gentlemen, while the ATSB may never know the reasons for why the pilot reversed his safe weather-related decision to return to Winton, we can provide the family of the pilot with some closure surrounding the accident, even if they themselves didn't understand his motivational actions either. Now, being able to work effectively with our international counterparts and manufacturers and regulators stands us in good stead, being able to identify unbiased, objective and relevant findings in our reports to hopefully enhance future safety and to bring such safety messages like this to you today. This accident highlights the need for VFR pilots to be aware of the weather conditions that are not conducive to VFR flight, and the accident highlights the risk posed to VFR operations and emphasises that proactive decision-making, diversion and alternates could be considered by all VFR, or should be considered by all VFR pilots, and above all, that self-imposed pressure to get the job done can be fatal. Thank you very much, ladies and gentlemen. Hopefully you've enjoyed that presentation, and I'll hand back over to you, Chace.
Thanks, Lee. If you don't mind, I do have a question or two for you on the accident, and perhaps that'll spur on some of our attendees as well.
Certainly.
I was just wondering, are there many other reasons that you've come across in your experiences that pilots decide to continue on with the flight, other than, I guess, a perceived pressure that they need to land at the destination? I'm thinking things like, my friends or my colleagues have gone on, I'm a bad pilot if I don't push on. Are there any other sort of things you see commonly?
Yeah, look, and having been a pilot myself and spent a lot of time as a flight instructor, you do see that in amongst students as well. But as flight instructors, it's your job to actually teach people about those, about get home-itis or get there-itis, as it's commonly referred to. Now, there's a number of reasons that people will do that, as you said before, Chase, like whether they feel as though they may be inadequate if they don't push on into that bad weather, or that somebody else could get through and they couldn't. Look, it all comes down to your willingness to accept risk. And to be perfectly honest, if you're a VFR pilot and you're taking the time to fly from A to B, what's a couple of extra hours? What's the big deal? If it means you have to stay overnight somewhere, in a hotel, think of it as an adventure. It's really about making sure that you make those safe weather-related decisions, rather than pushing the situation to end up in a tragedy.
Understood. Well, thank you for that, Lee. Really do appreciate it. It's, I think, a really useful thing, and we are very fortunate to have experts like Lee partner with us to discuss different topics. And as many of you probably would have seen, we do often partner with other agencies as well. A previous webinar, as an example, was with some senior forecasters from the Bureau of Meteorology. Now, what are some of the key things that we want you to take away from this webinar? What are some of the practical things we can do beginning with the very next time you go flying? Let's go back to, I guess, the basics. So you as the pilot in command are responsible for managing your own risks and to make safe decisions. The risk of flying in degraded weather conditions does not change depending on the stage of your flight. The safety of yourself and those in your aircraft depends on this. There is no getting around this fact. As a pilot flying under the visual flight rules, this includes ensuring that all of your flight is in VMC, visual meteorological conditions. If it's not VMC, you're in IMC. And anything in IMC can cause spatial disorientation, irrespective of the experience level of the pilot. Whether you've got 30 hours or 30,000 hours, weather conditions should be treated with the same amount of respect, because the weather conditions do not discriminate when affecting the pilot. If you don't fly as often as you'd like, or you're not current, or you know that there are gaps in your knowledge, take steps to suitably prepare yourself to make safe decisions ahead of your next flight. You need to be prepared to know what resources there are available to you and how to use them. As Lee alluded to in the case study, there were tools such as wing leveling function in the aircraft or air traffic services, and we need to be able to use them in certain circumstances. Don't back yourself into a corner. Always have an out. Whether this be your family, work, ATC, set expectations early and appropriately for your flight and each stage of the flight. I know we all have a desire to arrive on time or ahead of schedule into our planned destination, but this is often not a possibility. Don't be in a rush if you don't need to. Having a list of personal minimums, so a concept of what you as the pilot in command are comfortable going into, can assist with that process. And do as much planning as you can before the flight, as you can save time and mental energy once you're in the air. And during the flight, regularly assess the situation and have contingencies or backup plans if you do need to divert to an alternate aerodrome. As we alluded to before, that's part of that continual decision-making process. It's not a one and done. Lastly, we all know that there's many experienced pilots out there, and oftentimes pilots like to talk. There's experienced people all over our local airfields that have countless stories and abundance of wisdom to share. So get out there and talk to them about different scenarios, learn from their mistakes, gain some new strategies to handle different scenarios. These pilots may be able to share where the weather in that particular area usually comes from, what the wind might do at certain kinds of days, or a whole raft of other tips. We want to recognise your commitment to continuous learning with a digital badge for attending this webinar. And if you've stayed for the duration of the webinar, you'll receive an email from our digital partner, Credly, in the next day or so. You can add these badges to your email signatures, digital resume, social media, etc. I'm just going to pause. I see a couple of questions have come through. Bernardo said, cancelled countless VFR flights due to unfavourable weather, only to find out the weather was okay in the end. What advice do you have to remain safe and not distrust weather forecasts? I think it's a difficult one to answer blanket, because context is king with these sort of questions, in that the weather forecast is going to provide as best information as is available. So by you cancelling the flight, you're making the safe decision in your view, and I think it's better to look back on a flight knowing that the weather might have been good enough to get in than look back on it thinking I definitely shouldn't be up there. Everyone will have probably their own answers to that. And Phil's also said, I was flying in this area the day of the accident in company with another aircraft from our ownership group. You've got an instrument rating, unfamiliar with the avionics in the aircraft, so decided to hand over PIC duties to another pilot. And that's another way to manage a situation, using the resources around you, in this case, the resource being another pilot in the group. Thinking through that a little bit, that previous question a little bit more, Bernardo, if you do have questions, and this was a common theme in that previous webinar about some of the more finer details of that weather forecast, you can always call the forecasters as well. I'm thinking of the graphical area forecasts. You've got a phone number at the bottom of them, and you can go directly to the forecaster who has created that forecast. Jump onto CASA's Pilot Safety Hub for more information. The motto of the Pilot Safety Hub is, your safety is in your hands. It's up to all pilots to take the initiative and make use of all of the safety education resources that we provide and all the other aviation safety agencies provide. Now, whether you fly privately or for recreation, if you are an instructor, commercial pilot, if you fly every day or once every 3 months just to keep your recency, it doesn't matter. We can all aim for excellence and commit ourselves to bettering our safety knowledge, no matter how experienced we are. The other topics on the Pilot Safety Hub include non-controlled aerodromes, flight planning, controlled aerodromes and operations, and obviously what we're here for today, weather and forecasting. Links to the previous webinars, podcasts, videos, checklists, and all sorts of other great information, not only from CASA and not only from other Australian agencies, but partner agencies around the world, is available on that Safety Hub. Please keep an eye out and join us for the webinars in 2025. You can keep up to date by hitting the subscribe to our newsletters tab right at the bottom of the CASA homepage and clicking the AvSafety seminars box. Very simple process. We also would really appreciate if you could leave us a comment in the webinar in the chat window. Tell us what topics you do want to hear about. That way we can go away and make these events more and more useful going forward. Before we part ways, I'd like to just express again my thanks to Lee Ungermann from joining us from the ATSB. And whatever you guys are doing in the coming weeks and months, we hope you do your best to negotiate it safely, whether that be wet season up north or enjoying the warmer weather down south. Fly safe. And that's all from me today. Thanks very much.